Okay, welcome to the second part of video number 2. This is going to be dividing fractions. So in the last video, you should have gone ahead and filled out all of your notes for page 2, which is multiplying and dividing fractions. We actually only got to multiply on this page and in that video. So you should have this page completed. If you'll turn over to the back of that page and put a number 3, this is going to be page 3. And you can also go in and update if you have your table of contents already set up. If you've done that station in that video, then you can go ahead and add 2-3 onto your table of contents. Okay, so we're going to talk about dividing fractions. And we're going to specifically write down the rule that we multiply by the reciprocal. RECIPROCAL. Multiply by the reciprocal. So let me explain what that means and what that looks like in dividing fractions. So the reciprocal the definition of reciprocal is that you are going to invert the numerator and the denominator. So the reciprocal would be, so it would be changed to denominator over numerator. Okay, so that's all that means. You're going to basically invert or flip or turn over the second number. Now this is when you multiply by the reciprocal. So let's go ahead and get an example and we'll talk about that. Okay, so your example here is going to be 1/6 divided by 7/10. 1/6 divided by 7/10. Now, I do want you to know, and I won't, this won't come up very often, but it is possible to write your fraction like this: 1/6 divided by 7/10. Okay, now I know it's a little squished and probably I wrote it too small, but just so you know, every fraction bar means divide. So every fraction is a division problem. So you can also write it like that. But for these purposes, we're going to write 1/6 divided by 7/10. Now, when you multiply by the reciprocal, that means that you're changing two things on your fraction, on your problem, I'm sorry. The first fraction will stay the same. Your operation will change to multiply. Here it's divide. The problem tells you to divide. But when you divide a fraction, you actually are multiplying by the reciprocal. So that means I'm going to put the 10 over the 7. Okay? So this is our multiply. This is our reciprocal. That's your reciprocal. So here's our problem: 1/6 times 10 over 7. Now, when we do that, remember, now we go back to our rules about multiply. Okay, so we're going to think, can I reduce? I think it's very important that we ask ourselves that at this time. Is there a numerator and a denominator that both can be divided by the same number evenly? Well, 1 only has one number that it can be divided by, and 1 doesn't count because it doesn't change our value. So we cannot reduce our first fraction. Now, our second fraction, 10, does have a couple of numbers it can be divided by. It can be divided by 2, it can be divided by 5, and it can be divided by 10. Now, 7 only can be evenly divided by 1 and 7. So 10 and 7 aren't going to work. But if I look at my 6 and my 10, I can reduce these both by 2. So I'm going to divide the numerator and the denominator both by 2. So my fraction will change from 1/6 to 6 divided by 2 is 3. And 10 divided by 2 is 5/7. My 7 will stay the same. Now I go back to my rules about multiply, and I multiply straight across. 1 times 5 is 5, and 7 times 3 is 21. That is your answer, 5/21. Okay, let's do another example here. We're going to do let's do a mixed number example this time. This will be the first time that I've done an example with a mixed number. This is going to be 4 1/5 divided by 2 2/3. So what I'm going to have to do before I can divide these mixed numbers is I'm going to have to change them into improper fractions. Now the way that we do that is we say, in my 4, if I have 5 pieces each in my whole number 4, I need to find out how many I would have total. Well, 5 times 4 gives me 20. So that's how many fifths I would have in my 4. So I have 20. And then I have 1 in my fraction here. So I add my 1. So I'm going to multiply here. I'm going to add right here. Multiply and add. So we're going to go in a little backward C fashion. 5 times 4 is 20. 20 plus 1 is 21. And my denominator always stays the same. Okay, then I'm going to do the next one. 3 times 2 gives me 6, plus 2 gives me 8/3. So now, all I've done, I haven't changed any values. I've just changed the way that my fraction looks from a mixed number to an improper fraction. So now I have 21/5 divided by 8/3. Okay, so now I need to follow my rules of multiply by the reciprocal. So the 21/5 stays the same. I change my operation to multiply, and then I use the reciprocal. Okay, so now I can check, is there anything that I can reduce by? 21 can be reduced by 1, 3, and 7, but I do see a 3, but now don't be confused. You have to divide numerator and denominator. So I don't see that being a possibility here. 5 can only be divisible by 1 and 5, and none of these numbers are, this one or this one is not divisible by 5, either one of my numerators. So I can go ahead and just multiply straight across. I will have to show some work on this. 21 times 3, and 3 times 1 is 3, 3 times 2 is 6. So my number becomes 63, and I multiply straight across. 5 times 8 is 40. Now, because my question started off in a mixed number fashion, I'm going to go back and leave my answer as a mixed number. So I have to divide 63 divided by 40. Okay, top number always goes inside the box. You divide the numerator divided by the denominator. 40 goes into 63 one time. 40 times 1 is 40. I'm going to subtract. 3 minus 0 is 3. 6 minus 4 is 2. And so my remainder becomes my top number, or my numerator, 23, and the denominator will stay the same. So this is going to be equal to 1 and 23/40.